All right, let's look at the Theorem 1, parallelism in absolute geometry. All right, so we need to explain what the absolute geometry is. So absolute geometry is the geometry we have so far. And once we have the next axiom, parallel axiom, it becomes a Euclidean geometry. So everything up to now is absolute geometry. So what we have been doing was absolute geometry. Right? In absolute geometry, following is true. Congruent alternate interior angles implies two lines are parallel, right? And unfortunately, the converse is not quite true until we add another axiom. But let's prove this implication first. All right. Let's say you have transversal T meets line L at A and line M at B. All right. So you have two lines. All right. And I'm gonna draw it like this since I'm gonna have intersection point at some point. So you have a transversal like that. So it's T. And here is my L, and this is my M. All right, so intersection point here is A, and here's intersection point is B. All right, so we have that. All right, so we want to prove that these two lines are parallel. So 3, I'm going to say there are two possibilities. These two guys are not parallel, or they are parallel. So we have that. So this is just listing all possible cases. Right? Of that. So let's pick on the first case. Let's assume that L is not parallel to M. Right, so this is just a case 1. Right, which means that there's got to be an intersection point because they're assumed to be on the same plane already. So there exists some point, let's call it C, in the intersection L and M. So this is just coming from number 4 and the definition of parallel lines. Alright, so I'm going to call that point C right here. So there's going to be an intersection point C. Alright, then you can see that, alright, then for reference, I'm going to construct point D. So construct point D on line L such that between this condition is DAC. Right, so we have a point somewhere over here, D. Right, so this is just a construction theorem. So I'll just say construction theorem. All right, then number 7. Then we know that the measure of the angle BAD, which is the exterior angle, so we're looking at this angle right here, and it's going to be larger than the opposite interior angle. So you have, so this is going to be larger than measure of the angle ABC. All right, this is by exterior angle inequality. All right. But this is actually a contradiction because those two angles are alternate interior angles. So this contradicts to line number 2. Alright, so therefore, we know that L is parallel to M by rule of elimination, which was case 2. Alright, that's it. I hope that this was clear.